Everyone. My name is Ketan Reddy, working as an associate professor in Geetanjali College of Engineering and Technology. Welcome to my channel. My channel name is Jagdisha Reddy for Research. This video I will explain smart grid and technology subject. This is subject name smart grid technologies. The smart grid technologies I will discuss now. Unit 1, introduction to smart grid. These three topics I will discuss now. Conventional grid, microgrid and smart grid definition. I will share my PPT. Unit 1, introduction to smart grid, conventional grid, microgrid. Conventional grid means it is a interconnection of generation, transmission, distribution, and utilization. Conventional grid is only power flowing only one direction. Next, microgrid. Microgrid is the interconnection of generation and utilization. Generation means the here renewable energy sources we are using in microgrid, solar and wind and mini hydro and tidal like this. Microgrid. And smart grid is a two-way communication. It is controlled by electronically controlled. Next, this is the diagram of electrical grid. In this electrical grid, mainly four parts. One is the generation, second one is the transmission, third one is the distribution, and the fourth one is utilization. Therefore, in generating station, we have different types of sources is there. Generating stations. One is the hydro and thermal and nuclear, different types of power plants for generating power. Next here, this is the transmission line diagram. This blue color is the total transmission. In this transmission, have categories, transmission lines categories into two types. One is the EHV, extra high voltage AC transmission lines. Second one is the high voltage DC transmission lines. High voltage AC transmission lines are different voltage ratings. One is the first one is the 800 by 765 kilovolts and 400 kV and 220 kV and 132 kV. These are the different ratings of AC transmission lines. Next, this is the HVDC 500 kilovolts transmission line. This total. In this transmission line, input is step-up transformer. Step-up transformer connected to the input of the transmission lines and step-down transformer connected to the output side of the transmission lines. The main purpose of this step-up and step-down transformer interconnection is when we are transmitting the high voltage, the power is constant, and when we increasing voltage, the current will decreasing. The transmission line loss also decreasing. When transmitting high voltage, we are using the cable size also will decrease. This is the definition of electrical grid. An electrical grid is a network of synchronization power providers and consumers that are connected by transmission and distribution lines and operated by one or more control centers. This is the conventional grid is the just interconnection of generation, transmission, distribution, and utilization. Next, these are the diagrams of electrical grid. In this electrical grid, here generation, transmission, distribution, and consumers. In generation, have four sources. One is the thermal, second one is the hydro, third one is the nuclear, and fourth one is the renewable energy sources, renewable and solar and wind. Next, transmission lines. Transmission lines classified into two types. One is the HVAC, second one is the HVDC. And distribution lines again. Distribution lines are AC distribution and DC distribution. And consumers are three categories. One is the industries and commercial and domestic. This is the vertical structure of transmission line, generation, vertical lines of smart grid, vertical structure of grid, generation, transmission, distribution, and consumers. This is the microgrid diagram. In this microgrid diagram, here total 7 blocks is there. One is this is the microgrid controller. In this microgrid controller, I have connected 4 inputs. One is the solar panel, second one is the wind turbine, third one is generators, and fourth one battery storage. These 4 are microcontroller inputs and microgrid inputs. Microgrid outputs are microgrid controller inputs, and microgrid controller outputs are critical loads and utility providers. These two are output side loads. Next, this is the smart grid. In the smart grid is a two-way communication. It is there are many features in the smart grid. One is the self-healing and the market self-healing. The power unit price also varying based on time to time. And in this diagram have mainly 7 blocks. First one is this one is the generation, transmission, distribution, and this is the customers. These 3 more blocks added in smart grid. One is the markets and operators and service providers. The function of generation here, power generating, and transmission lines, transmitting the power, and distribution lines, this power will distribution this distribution system, and here consumers are loads. And the markets means the price of unit price of the electricity will varying from hour to hour. When renewable energy sources in solar is when power generating more power, at power the unit price is will decreasing. When have demand, load side demand is high, the market unit price is high. Based on generation and load, the market unit price will vary. Operators, it maintaining always supply and load demand equal to supply, load demand equal to the supply generation. When have more demand, the generating power also will generating more. When the load demand is very low, the generation will also stop few generators, and it maintaining always balancing load, supply and load. Here the service providers providing service per end users. When any problems occurs in distribution side, the service providers will always providing service here. This is smart grid. Next, these are the comparison table of existing grid and smart grid. Existing grid is electromechanically device. The here smart grid is a digital device. Next, here existing grid is one-way communication. Smart grid is a two-way communication. Next, existing grid is a centralized generation. Smart grid is a distributed generation. Existing grid is a limited sensors. Smart grid is operating throughout the sensors. Existing grid, we are operating through manual monitoring. Here, the smart grid is automatically self-monitoring. The failures and blackouts are more in existing grid. Failures means any problem occur. The transformers and circuit breakers and transmission lines will problem. In blackout means the total power will turn off. Okay, this is existing grid. Next, adaptive and highlighting the smart grid. Next, the existing grid is a limited control. Here, pervasive control, and existing grid manual restoration, and smart grid is the self-healing. These are the differences of existing grid and smart grid. Next, this is the diagram of this table is the comparison of microgrid and smart grid. Microgrid, it is a small scale power supply network that is designed to provide power for small community. And smart grid, it is a large scale power supply network that is designed to provide for big community. Next, microgrid, it enables local power generation for local loads. Next, smart grid, it enables local power generation for local as well as outstation loads. Next, the microgrid is the size of microgrid range from housing estate to municipal region. Next, the size of smart grid is always bigger than municipal regions. Next, microgrid is permits the distributed generation at small scale as compared to smart grid. Next, to smart grid permits the distribution generation at large scale compared to the microgrid. Next, to the small substations at individual microgrids monitoring and control the power distribution using microprocessor. In this microcontroller, in this microgrid, the microcontroller controlling the total power supply. Here, the distribution of total generation carries out economic with LDC, load dispatching center. Here, the transmission lines and wheeling loss are less. Here, the transmission lines and wheeling loss are more in smart grid. Okay, thank you.